Hey, seventh graders. So your activity today is called Elk and Wolves in Yellowstone. Over the past couple weeks, we've really been looking at how a population size either increases, decreases, or stays the same. And this is going to be really no different, but we're going to kind of add on to it and show how another population might affect one population. So in this case, elk and wolves. And this is really important. We'll talk a lot about predator and prey relationships and how they fluctuate with each other. But the main thing that you guys are going to be doing today is you guys are going to be taking a data table that has some incomplete data. You're going to be filling out that data table, which is going to be great. If you guys are watching this right now, you're doing exactly what you're supposed to be doing. And I'm going to give you guys a lot of help. And I'm really going to go through and fill out most of this data with you guys. So you guys will have half of this already done for you by the time you're done with this activity. Okay, so and then the other half of that is you guys are going to be taking that data and graphing it, and you're going to be able to look at two different lines on a line graph. One's going to represent your wolf population, one's going to represent your elk population, and then we're going to see kind of how they relate to each other and what those two populations look like. So your learning targets for today are: I can calculate data to reflect the change in the size of a population, and I can graph the changes in the size of a population. So again, we're really going to focus on, is our population increasing, and why is that? Are we having more births? Are we having more deaths? Are those equal? Same thing with decreasing. If one of our populations is decreasing, why is that? Okay, what's attributing to that, and how does that other population kind of influence that? All right, so here's a little background information for you, and you guys will watch a movie that kind of solidifies this here in a second. So in 1926, all wolves were removed from Yellowstone National Park in an attempt to regulate wolf populations. In the time following their extrication, biologists noticed extreme changes to the park. First and foremost, they noticed a large increase in elk populations. They tried increasing the number of elk hunting permits in the area, but even that didn't slow the population growth down. Due to the increase in elk, among other things, they noticed that certain plants were now being overgrazed. This overgrazing led to a lot of changes to other populations as well as to the landscape. In 1995, they reintroduced wolves to Yellowstone Park in the hopes that Yellowstone would return to its original landscape and see some other populations of organisms return and thrive again. For this example, we will be using some fictional numbers to help us understand the relationship between wolves and elk in the wild. So obviously the model that I'm representing is very much a real model, but I did just fabricate the numbers so you guys can't say like, oh, in this study right here. No, I made up the numbers to kind of show you guys what this relationship between predator and prey look like. So we will assume our population of elk before the reintroduction of wolves is 2,000, which in all reality, it's, if you've done any of that case study yet, you guys have seen it's really more like 20,000, okay? But we're going to use some smaller numbers that are easier to work with, so I scaled it down a lot so when you guys are graphing it, it's not so confusing. All right, so moving on, I want you guys to right-click this link right here, open up this video, it will take you into YouTube, and you need to watch this little video called How Wolves Change Rivers, okay? It looks specifically at Yellowstone and basically frames out what that 100 years between removing the wolves from Yellowstone, really more 75 years, and looking at reintroducing them in 1995, what a difference that made and the changes they saw when there was no wolves and what happened after wolves came back. So it's kind of an interesting little video. Okay, that's the first thing you guys will do, and then we're going to go through and I'm going to talk about these next three slides, and I'm going to do a lot of it with you. I'm going to kind of skip around for you guys, but first I want to go to slide 6 and show you guys what your data table looks like. So when I explain your directions, it's going to make a little bit more sense. So you guys can see I gave you guys this incomplete data table. Your years are over here on the left, so we're looking at 1994, which is the last year that there was no wolves in Yellowstone. And then our first year that we had wolves back in Yellowstone was 1995. And then I just had some data for 10 years roughly. So in about 10 years, what change did we see in these populations, okay? You guys can see 1994, we had no wolves. And then this is when we introduced, so in 1995, we'll say about 10 wolves, and that's fairly close to accurate. I think the actual number is like 11 or 12, but we'll go with that. And again, these numbers are going to be a little bit easier to manage than what the actual numbers of them are. Okay, so you guys can see how our wolf population fluctuated you know, just looking at the numbers, you guys could probably tell a trend, but when we get it graphed, it will make a lot more sense. So that's going to be one set of data that you guys are graphing right there, is over this 10, 11 year period, how did our wolf population change? So that's going to be one of your guys' lines. Okay, your next one is all of this other data right here, and we're going to simplify it and do some math and make it look really clean. So what I gave you guys is each year how many elk were born. Okay, so that's going to be just one column. There's no math you need to do with that. These two columns, however, is where the math comes in. So this column is the number of elk that were eaten, so they became prey. And this is just natural deaths. You know, elk die. Maybe they hurt themselves. Maybe they are just old and pass away. Okay, so these are going to be natural elk deaths. Maybe they drown. Maybe they fall in a hot spring. I mean, they are in Yellowstone after all. Okay, so this number is going to represent, again, the natural elk deaths. So if we look at those two columns, we would definitely say, well, you know, whether they're getting eaten or whether they're dying of a disease or something else, those still count as deaths. So if we're looking at this column right here, total deaths, well, how do we find that? Pretty easy. We see how many are eaten and we add up how many die naturally. That's going to be our total deaths for each year. It might be helpful for you guys to just go down this column and add up all of your deaths. Okay, I'm going to work through 1999 with you guys. Okay, and then once we got that data, then I'm going to go and help you guys graph about half of this. We'll look about graphing half of the wolf population and then half of the elk population together, and then you guys will do 2000 to 2004, so that 5-year period on your own. So I'm going to do half of this for you guys. Okay, and then finally we're going to look at change in the elk population. So if we're having more elk being born than we're having dying, we should see an increase in our elk population. So we're going to look at what we had the year before, which was 2000. And we're going to add to that, all right? We had more births than deaths, so we're going to add to our population. Our population is increasing. However, on the other hand, if we have more deaths than births, which we very well may see with the introduction of wolves, okay, then our population is going to be decreasing, and we're going to want to subtract our population and make our population smaller. So again, as we work through this, you guys will understand what it looks like, and you'll be able to complete the rest on your own. So let's jump back to slide 4. It's kind of your instructions. So it says, first and foremost, calculate the number of elk deaths, add up the number of elk that were eaten, and the number of elk that died naturally. That's going to be that total deaths column. So you guys can go down and do all 10 years right now if you wanted. Okay, we're going to do 5 together. Then your next step will be calculate the change in the elk population by subtracting the total elk deaths from the total elk births. So let's go ahead and just get those out of your way. If you guys have a calculator, you want to use your cell phone, you guys want to use your laptop, that's fine, but you guys can also use this link right here. So right click it, open your link. I minimized mine for convenience so I can kind of put it right next to my data table. And I'm going to go ahead and just take care of step 1 here, calculate the total number of elk deaths. So that's going to be, back to slide 6, this column right here. All right, so we're going to look again, the elk eaten and the natural elk deaths, and we're just going to add those up. Some of these I'm obviously going to be able to do without a calculator. So in 1995, 400 elk were eaten, but 100 died naturally. So that year, in 1995, a total of 500 elk died. Okay, if we look at this next one, we can say, all right, 480 plus 240, so 480 plus 200 is 680, plus another 40 is 720. And we can double check that with a calculator if you guys are unsure or you do not trust my math, which sometime when I'm filming these, my brain gets a little jumbled. So 240, look at that, I'm good at math. Okay, this one, we've got 640 plus 500. So that's going to be 1,140. Okay, 600 plus 500 is 1,100 plus another 40. 880 and 180. So 880 plus 180. Oh, what did I just do? 880 plus 180. You guys probably already have this done mentally. 1,060. I just want to make sure I don't make any mistakes. Okay, so again, this is the last year of data that I'm going to do, so you guys can go ahead after I finish this, pause this video, and then finish doing this column here. It will make your life a little bit easier. Notice that in 1999, our elk deaths that naturally occurred started to go down. I want you to stop and think about why that might be. Okay? look at your other data that you collected. Why do you guys think we went from like, all right, 100 deaths, 240, 500 natural deaths, maybe they had a bad winter that winter, 180, and then all of a sudden 26, 2, and then 0. So what do you guys think is happening in our population or our little ecosystem here that's causing less elk to be dying naturally? Okay, think about if you were a wolf and you were hunting. What elk would you go after? Okay, what's going to be the easiest for you to hunt and kill? Is it going to be the healthy young elk, or is it going to be those elk that might be prone to dying naturally? Okay, all right, so anyway, moving on, our last little year I'm going to calculate for you guys is 1,120 plus a whole 26 natural deaths. So in 1999, we had a total of 1,146 deaths of elk. Okay, again, go ahead, pause this video, finish the rest of this column here. Should be fairly easy for you guys. You have a whole lot of big numbers to add. Okay, all right, moving on, if we go back to our directions, step 2 tells us to calculate the change in the elk population by subtracting the total elk deaths from the total elk births. And really, we're just going to look at, all right, we're going to take our elk births and we're going to subtract our elk deaths. And these numbers should make sense to you guys. So elk births minus elk deaths right here, the numbers we just calculated. So if we look right here, total in 1995, we had 800 being born, 500 dying. So obviously if we subtract this, we're going to come up with 300. But let's talk about the significance of that number. Okay, did we have more elk being born, or did we have more elk dying? Okay, what does that tell us about whether our population is going to increase, decrease, or stay the same? Okay, if you said that your population should increase, that's correct. You guys should have a positive value for this number. It should be 300, okay? Meaning that we're going to add 300 elk individuals to our total population of 2,000. So at the end of 1994, we had 2,000 elk. At the end of 1995, we're going to have 2,300 elk. Okay, so I want you guys to go ahead and we're just going to do these ones together. We're just going to figure out the elk born, the elk deaths, and then what the difference in those two numbers are. And we're going to fill out this column too, and then I'll have you guys do the same thing where you finish doing that column, you pause, and you do that column on your own. All right, so let's look at 1996. So this is the second year after wolf reintroduction. We had 920 deaths, and I'll pull this up even though I may not need it. 920 being born. And then if we look right here, we calculated 720 dying, so minus 720. So always take your births minus your deaths. That's going to give us 200. Again, did we see more elk being born or more dying? Okay, if you said born, you're correct. And that means that our population is going to increase. Okay, so 2,300 plus 200 is 2,500. Okay, so our elk population is still on the rise even 2 years after having wolves back in the park. All right, the next year we had 1,000 elk being born. And we had 1,140 elk dying. So again, we're going to take our elk births, and then we're going to subtract our deaths. And I'm going to show you guys what happens with that number, and let's again talk about that significance. So we had 1,000 elk being born minus 1,140 elk that died that year. That gives us a value of negative 140, okay? This is where we see a change in our data. Did we have more elk births or more elk deaths this year? Okay, more birth or more death? Okay, you should say, all right, 1,140. We had about 140 more elk that died this year than were being born. So that naturally decreases our population, hence the negative. That means we're going to subtract it from our population rather than add it. Okay? All right, so moving on to the next one, we had 944 elk that were born that year in, what was that, 1998? And then 1,060 died, so minus 1,060. Notice again that you guys have a negative value. You have a negative 116. Again, we had more deaths than we had births, so we're going to subtract 116. Okay, last year I'm going to do for you guys. You have 996 elk that were born. That number's right here. And we had 1,146 that died. So minus 1,146, Again, this should be another negative number because, again, we had more elk that died than we had being born. So we have a decrease on our population. Our elk population is slowly going down. Okay? Last but not least, it tells you guys in your directions to figure out what the end of the total population was for the end of that year. So again, if the births are higher, you're going to add it. Okay? You're going to add that change to figure out your total. And then if your deaths are higher, which we've seen in the last 3 years, you're going to be subtracting. And that kind of naturally is going to happen by having those negative numbers. Okay, so back to here, we had at the end of 1996, elk population of 2,500. And we are going to subtract 140 elk. So 2,500 minus 140 elk equals 2,360. So our population went down just a little bit there. Okay, same with this year. We had 2,360 last year, so we can keep that number on our calculator. And it looks like we're subtracting 116 now. So 2,244. So again, our population's going down. The last little set of data I'm going to do for you guys is, at the end of 1998, our population of elk was 2,244. But we're still dying out a little bit more, so we're going to subtract another 150. So 2,244 minus 150. Pause as you guys need to record data. That's totally okay. So 2,094. Okay? All right, so you guys will be responsible if you haven't already finished calculating your total deaths by adding these two columns up. Finish figuring out what your change in your elk population was each year by taking your births and subtracting your total deaths that you guys just figured out. And then go ahead and either add or subtract to your previous population years to figure out that at the end of each year, what is your population of elk. Okay, let's go ahead and take a look at your graph. This is the last little part that I'm going to do for you guys before I release you guys to finish. Notice that this chart's a little different than most charts you guys looked at. We have two y-axes, mainly because we have two populations that we're going to graph. On one hand, we're going to graph our population of wolves. But notice that our highest number for wolf is only 28, so we really don't need to have the same y-axis as, here we have at least 2,500 being our highest. I don't know what the rest of your data looks like. You guys are going to have to figure that out. But we're going to kind of do a little, probably between 2,000 and 3,000. We might go a little bit below 2,000 just to be safe. All right, so on one axis, we're going to go ahead and click, and this is going to be our wolf population. So we're going to go ahead and put number of wolves. Okay? This other side is going to be our elk. So we're going to do number of elk, or elk population is fine. And then our x-axis is going to be our years. I'll let you guys come up with a title for your chart. Remember, it should reflect your y-axis, which is number of elk and number of wolves, and your years. So over a 10-year period from 1994 to 2000, however you guys choose to slice it, that's up to you. Okay, and then we're going to go ahead and just use our draw tool from here on out, and we're going to say, all right, this is 1994, and then maybe we do like every 95, 96, 97, 98, 99, 2000, 2001, 2002, 2003, 2004. So you guys will have probably this whole part of your graph that you won't use, and that's okay. I might shorten that up for you guys just so you have it. Okay, all right, so this again is going to be 94, 96. You guys can fill in the numbers. I'm just going to do every other for now. 98, 2000, 2002, 2004. So the first thing that we're going to graph together, and again, I'll only do about 5 years for you guys, is your guys' wolf population. So you guys are going to choose a color, and I want you guys to just kind of do a highlight to show me which color you chose. For wolves, I'm going to do blue. Okay, so my blue line will be my wolf population. Okay, I'm going to go ahead and grab a pen. I'm going to make it blue because that is my wolf population. And then I'm just going to graph these numbers and say, all right, in 1994, we had a big fat goose egg for a number of wolves. So we're going to go here and say, all right, 1994. Let's go ahead and set, I guess I forgot to set your guys' axis with you guys. So at the most, or at the least, we had 0 wolves. At the most, from what you guys see, we had 30. So you guys can kind of frame out in there. Maybe you go, all right, this is 10. This is 20. And that's 30. So that's roughly about equal. I can't believe I just guessed that and got it right. Okay. So then here would be 25. Here would be 15. And here would, oh, that was my bummer one. Here would be 5. So it's not exactly accurate, but it is good enough. Okay. And you guys can definitely do the same axes as well. That's okay. So in 1994, we had 0 wolves. So our first data point's going to be right there. In 1995, we had 10, 12, and then 16. So I'm just going to kind of take it 3 points at a time. So here we had 10 wolves. So here's my line for 10. 1996, we had 12. So roughly about right here. And in 1997, we had 16, and then 1998 we had 22. So here's 16 right above 15 here. And then 98 was 22, so just above 20, about right there. And then my last set of data that I'm going to do for you guys is 1999, which had our high of 28 wolves. So here's 1999, we're at 28 wolves about right up here. Okay, and then you guys will play a little game of connect the dots as best as you can with the draw tool. You guys will probably be a little bit better at it than I will. But this is going to be what your guys' wolf population looks like. You guys will need to finish graphing from 1999 to 2004. So you guys can finish that line, pause it, and do it right now. You have all the data ready for you guys. On the other hand, though, you guys are going to have your wolf population. So I'm going to go ahead and say, or excuse me, my elk population. I'm going to do that in red. Okay, my axis is going to be a little bit different for you guys because you guys could be going from anywhere from maybe 1,500. We'll go at a low point. So let's say maybe 3,000. That should probably frame out our best here. So we can say, all right, 1,500, let's do, I think we could probably do about the same. This will be 2,000. Actually, let's do 1,600 here. Okay, and then 2,000, and this will be 2,500. Okay, and again, we're going to do the exact same thing. What is the, so this is going to be a red color. What is the population of our elk in 1994? The answer to that should have been 2,000. Okay, in 95, it was 2,300. So we went up. 2,000, here's 1995, 2,000, about right there. Doesn't have to be accurate. Actually, let's go more like right there. In 96, we were still on the increase, so we're at 2,500. That should be an easy number for you guys to graph. 2,500 and 96 is right there. And then we kind of start to go down from there. So I'm going to go ahead and connect those two dots. And then from there, we're starting to drop down. In 97, we were at 2,360, so about the same as our data from the year prior, so about right here. In 98, we were at 2,244. So about, let's see, 20, about right there, so slightly below. So we only had a little decrease. And then finally, our last set of data I'm going to give you guys is 1999, which we dropped down to about a little over 2,000, about 2,100. So you guys can go by estimates. This doesn't have to be perfect. Mainly the thing you guys are going to want to see is the trend. So here's 99, here's 2,000. So we're about right there, we'll say. Okay, so this should be a rough estimate of what your guys' graph looks like. Again, you guys will need to finish the last 5 years of that, so you have 5 more data points that you need to graph there for wolves. Okay, and then again, don't forget to put a title, one that reflects your guys' 2 different population of elk and wolves and the number of years. Okay, to finish up, you guys have some questions to answer. I know this has been a long video, it's been a long lesson for you guys, but I think you guys will get a lot about it. Just answer these 8 questions. When was the wolf population the highest? So tell me what year. What do you think would happen to the elk population if Yellowstone had the wolves not been introduced? So if you guys were to just look at graphing that elk population, what do you think would happen? Zero population growth is when you guys basically have it staying the same. So did you see that happen with the elk? When was it about the same, or when was it closest to being zero population or staying the same? So you'd see a level line. Other than births and deaths, what are some ways a population of animals can change? So you guys are looking at this same concept when we did the migration dice game with the zebra. Okay, so look at the wolf population from 1994 to 1995. What happened there? Okay, what happened? Why did we go from 0 to 10? What did we do? Okay, all right, and then if the wolf population increases, what do you think would happen to the elk? If the elk population increases, what do you think would happen to the wolf? That's supposed to say wolf. I'll fix that. And then if the wolf population decreases, what do you think would happen to the elk? And if the elk population decreases, what do you think would happen to the wolves? Again, I'll fix those two questions for you guys. Finally, do your guys' little wrap up here and turn it in. You are done. Hope you're having a great day, and I'll talk to you soon.